Good evening. Welcome to my program. My name is Dinesh Vijayavardhana. Today we're going to discuss a topic of wave. It's actually the continuation of last topic that I discussed. In my last topic, I discussed about what is the wave and what medium it occurs and what are the characteristics of wave. Today we mainly going to focus about waves. There are types of waves. So basically, first we're going to start with mechanical waves. So let's get on to the topic. So if you consider the mechanical waves, um, in order for mechanical wave to occur, propagate, it need a medium. So that's a basic requirement for a mechanical wave to for propagation. So if you consider mediums, it could be water. Example, a tide, water tide that occurs in water, like in the sea tide. Or it could be either air. The medium can be either air. So all these mediums are fluids. It could be something else too. So let's get into the air. Air, it could be sound waves, or it's just the normal sound that we hear day-to-day life. Or it could be a vehicle sound, it could be a train sound, or it could be a thunderstorm sound. Anything, any sound that occurs in the air is reach us by a sound wave. So that is also a mechanical wave. And third type is created in a solid material, like a metal string, or a nylon string. So that sort of wave can happen is, for one example for this type of mechanical wave is a guitar. You know, so like a guitar, and you got strings all around it, and you got the tiding points. So when it's attached like that from here to here, and when you vibrate, when you push towards it, it creates a wave. Even though it's very hard to see, it's high frequency, therefore it's very hard to see how it moves, but there are waves that create in this metal surface, also a mechanical wave. Now, and now we're going to discuss what are the types of mechanical waves. First, let's look at the first type. It's called longitudinal waves. Longitudinal. The second type is called transverse waves. So when you look at the longitudinal waves, so let's discuss the first one. Basically, longitudinal waves is that, let's look at a wave first, such as a wave that occurs in a water. That's the medium water. If the direction of the wave, so that's V, okay, that's the position, 0 position before it moves, and then start moving along the time, and next position it could be up here. So the wave actually has moved. So this position, it could be V1, and it could move to the next level. So it keep moving. So the actual speed of the wave, or actual direction of the wave, if it is same as these are the particles of the wave, the actual medium, the water medium, there are the particles. These particles also moves. Therefore, they push against each other, and that carries the wave. So therefore the particles also has a velocity. So if the direction of the particles and the direction of the actual wave is same, then it's called longitudinal waves. It is the same direction. So once again, if the direction of the wave and also the particles of the medium that carries the wave are in same direction, they all called longitudinal waves. So that is the first type. In order to discuss this, also we can draw like they call slinkies, or like a plastic ribbon. It's like a spring, but it's a plastic ribbon. It does not have the same toughness as a spring. So when you get a slinky, when you have a slinky and then we give a push on this side, that's a push. So in the next moment, when you give a push, these areas will squish, so it will look like that. But it starts moving because we push from this direction, the velocity in this direction. So next moment it will be like this. So here the compression is up here, and next moment the compression in the middle. And again, if you look at another time, so this might be first second, and this might be 5 seconds, and this must be 10 seconds. This will look like that. So the actual compression point just has moved from here, this position, to up here and to up there. So that actual particle has, so in this scenario, there are things we need to understand is that this is also longitudinal, how we discussed the longitudinal waves. There is a compression occurs in this case. So this is a solid material like a slinky, a plastic ribbon. When you give a push, it creates a wave and it moves forward. And this particular compression point is happen because compression happen because the actual particles of the wave is stay closer to together. That's why there's a compression happens. So even in this scenario, when particles moves in this direction, the actual compression happen in here. So if you magnify it, if the particle moves this direction, compression happens here, because compression happen here. That's compression. And because there is less particles here, it will be rarefaction. They call rarefaction. So rarefaction and compression. So rarefaction here is that where the particles are apart, like this point, or like this point, there are rarefaction. So once again, compression is the where the particles stays together during the wave. Rarefaction is the particles stay apart during the wave. Let's discuss furthermore into this. Let's discuss the transverse waves briefly. The transverse waves is if the direction of the wave is perpendicular to the direction of the actual particles, then they are called transverse waves. So in the longitudinal wave, it's the same direction, but in transverse waves, it's 90 degrees apart. So best example for this transverse waves is water. Let's look at the water wave like that. That's water, and in this direction there will be peak, that's peak A, and that's the bottom line, and that's peak C. Basically the transverse waves happen to be like moves up and down, up and down, up and down. So there are waves that moves up and down. So if you look at this one, the actual motion of the wave and the particles motion, these are the particles, they moves in the same direction. So therefore that is longitudinal. But in this scenario, the wave moves in this direction, but the particles moves in up and down. That's a water wave, a tidal wave. So particles moves up and down. Particles moves up and down. But the wave, these are the waves velocity in this direction, but the particles moves in opposite direction, or not the opposite direction, it's actually perpendicular to the direction of the wave. So these are the VP, that's up and down, that's the direction. So these are called transverse wave. But in some scenarios, if these moving up and down, moving perpendicular to the direction of the wave and moving as the same direction of the wave can happen in both. Both can happen in same wave. So that will become a bit complex. But for here now we discuss it separately because that's the usual scenario. Longitudinal and transverse waves happen separately. So that's all about today's discussion about the wave. We'll discuss this topic in more detail and move into a next topic in my next lesson. Thank you so much for watching. Bye for now.